Hello everyone, thank you very much. So first to clear up a mistake that we made when we submitted the talk, it is not Strangeling, your native apps to Flutter, which was the original spelling. It is Strangling. Yeah, so thank you for having us. Thank you for being here to the talk, and thank you to GDG for having us. We're really excited to be here. We're also pretty nervous, so go easy on us. It's both of our first time speaking in public. Well, in a formal setting, at least. My name is Matt. This is Mfundo on the side. He'll be joining me midway through the talk. And we work at a company called Skynamo based out in Stellenbosch. We work on the main product, which is a mobile-first field sales management app. And it's been in development since about 2012. Yeah, so let's just jump into it. Who remembers what smartphones used to be like back in 2012? Like anybody who's owned a first-generation smartphone knows just how much they've changed. Life was a lot simpler back then. WhatsApp used to charge you a yearly fee, if any of you remember that. And you could sell a phone for 3 times its value if it had Flappy Bird on it. More importantly, the memory available, the CPU, the camera, the hardware, everything around that has upgraded significantly since then. And that's just speaking about hardware. If you think about where the software has gone in the last 10 years, it's like really crazy how big of leaps and bounds we've taken. We spoke earlier today about Min SDK 14 and the security patches around that. It's really changed a lot in the last 10 years. Even the development languages have changed. Back in the days, you did Obj-C in Java, and now the languages for mobile dev are mostly Swift and Kotlin. So unsurprisingly, 10 years is a really long time. And in our repos, we still have code that's in the commit message says initial commit 10 years ago. So is this actually a problem, right? Should we be worried about the ages of our code base? And if so, what should we do about it? Well, since we're at the start of a talk, I'm sure you are dying to see what I have to say about it and what Mfundo has to say. So the answer is yes, there are problems with having a very old code base. I clicked the wrong button. There's the bird again. Cool, so from a tech perspective, the main problems with an old code base are maintainability and upgradability. In the mobile space, this problem is doubled because you have 2 repos in iOS and Android. And if you made decisions 10 years ago on one of those platforms, you get bound to those decisions if you don't make any updates in that time. There's also the simple fact that your code gets stale over time. Stale code can be anything from code that users never touch to code that uses libraries and functions that haven't been updated in 5, 6, 7 years. They've stopped getting security patches and they just don't provide a good user experience anymore. And you also get a third problem which could happen, which is that at some point your original developers may leave and you end up in a situation similar to this. I don't know how many of you have been following Elon Musk's escapades in Twitter, but he basically turned off a bunch of bloatware which happened to be used for multi-factor authentication, and nobody could sign into Twitter anymore. So it's important, like this leads into one of our things on a business level, which is that complex systems take really long to develop and have a lot of background knowledge required to keep them up to date. It also becomes really hard to hire into those roles where you're requiring people to know Obj-C and Swift and Java and Kotlin. And this becomes like a real issue in your business. You just can't find people to do the work. Unless you pay them lots of money. But then typically you get a guy who looks like that, and he's been working non-stop at the ripe old age of 26. So the last problem we have is that parity across your platforms becomes really hard to maintain. If you have 2 repos that were both made 10 years ago and you're developing on Android and on iOS, your apps are bound to drift apart. And over time, these small changes become magnified. And if your users happen to switch from Android or iOS, they're going to get vastly different experiences, and they're just not going to enjoy like the switch. At Skynamo, we've been dealing with this problem a lot, and this kind of leads into our big question, which is how do I move my native apps to a cross-platform technology while supporting a business? So what are our options, right? The classic one is we could just do a ground-up rewrite. We can both the iOS and Android repos, and we can just start again. This does solve our tech objectives, but it does absolutely nothing for the business. It costs hundreds of thousands of rands, could take months to develop, and there's a good chance that you end up right back where you were with a monolith that is unmaintainable in another 5 years. We could also write a new app while maintaining the old one. This effectively means you're writing your features twice, and it also means that your users aren't going to get the new features that you want to test on them, that you want to give them extra value for, and you basically become, like you start moving back from agile to waterfall development, where everything has to be done before you can move your users onto it. We could also live like a hermit on a mountain, forget that it's a problem, just deal with it down the road, but there's a big risk of that biting you in the butt down the line. Or we could use this technique called Strangler, which is why we're here today. So, despite its name, strangling is not the process of killing your teammates for their sins of the past. It is a term which basically is analogous to how a vine might take over a tree. So if we view our tree as a creeper with existing functionality, if we view our tree as the original code base and a creeper as the new work you want to do, you can break it up into 4 stages. In phase 1, you have your tree with the creeper not involved at all. You have phase 2, where you have your tree and the creeper's slowly making its way up and slowly taking away nutrients from the main tree. In phase 3, your creeper is completely enveloping your tree, and you don't have, it's hard to tell what is tree and what is creeper at that point. And in phase 4, the original tree dies because all the nutrients has gone into your creeper, and you effectively are left with just creeper and no more tree. So if we step back from the analogy, we can say the tree is our original code base, the creeper is new work that we want to do, and the creeper will and the new work slowly replaces functionality on the old work until all of the original functionality has been replaced and improved upon, and all you're left with is creeper and new code. So why would we do that, right? Why would we do that instead of a rewrite? In our business, we've seen a lot of success with it on the web, where we've strangled out our monolith into microservices. This is a little bit different in the mobile space, but you can use similar principles. You also give yourself the ability to rewrite your app piece by piece. So you don't have to do the full investment of taking your app, scaling it back, redesigning everything, and putting it all in one code base. And one of the Strangler's core principles is that anything that you replace, you should improve upon as well. So you don't pick work that you want to replace just for the sake of replacing it. You pick work that you know will add extra value to your users. Outside of the analogy with a tree, it means that every time we update or augment a feature, we will opt to rewrite that feature in a cross-platform solution, which sounds amazing, but obviously quite hard. So how do we do that? Well, we've actually tried this before we even knew what the Strangler pattern was. In the early days of React Native, we made a half-assed attempt at writing some of our features in React Native and embedding them into our platform. I say half-assed because we didn't really know what we were doing, and we didn't plan well enough, and we also just didn't have the web skills required to make it work. We also ran into problems with React Native shifting underneath us a lot. So every 2 days in 2018, if anyone's been using it since then, React Native would update its versions, and every time a version changed, there would be a major version bump, it wouldn't be a minor version. And that meant that things just stopped working that we wanted to work. But to some degree, we did get it to work, and we learned a lot from that experience. We also have tried just ignoring the problem. This worked for a while, but the gnawing feelings of our apps drifting further apart and the fact that we weren't actually solving any problems meant that this wasn't a long-term solution. And that brings us to our new approach, which is full arsing a strangle rewrite in Flutter, not full strangling our teammates. Using the learnings from React Native experiment, as well as our approach on the web, we feel really confident, and we've been successful in strangling a few of our features already. We're hoping that by doing the strangling approach, we can write code once and have it work on Android and iOS. We don't have to start again to move to Flutter, so we don't have to rewrite our apps from the beginning. And we'll be able to systematically replace all old code for our customers' benefit. I'm now going to hand over to Mfundo, and he's going to give you a little bit more detail on what we've done.
Hello everyone. So thank you, Matt. My name is Mfundo, and I'll basically take you through the technical side of how we actually strangled our features into Flutter, not our teammates. So basically with this new approach, the idea is that we slowly migrate our existing features into Flutter, and then the new features will be developed in Flutter. But how these are developed is that they developed in individual modules. So at a later stage, all those individual modules then you can combine into a single application, which would have caught up with our legacy code. So the next step of this was then to actually figure out how this works. So how this works is, like I said, we develop old features in Flutter, and we either develop it as a full screen activity in Flutter or just a view, as you can see there. And then this is then embedded into the native code as if it were originally there. So it just blends in. But then through Pigeon, which is a library in Flutter, we can then pass through data from the native code, either the iOS app or the Android app, into Flutter. But then, after having figured out all of this, it was all good and well, but then we needed to figure out what was then the next step in our implementation, which was then identifying the part of our existing code that we're going to strangle. And for the sake of this presentation, we're just going to go through how we strangled the email into Flutter. So basically how this works is on click of an item in a recycler view, we're basically going to open up a new Flutter activity. And that Flutter activity will receive the data from native and then basically show it on Flutter. So this was basically our first attempt at basically proving our concept, and it was simple enough, and then I hope it will be easy enough for us to follow along. So we had to figure out, okay, what was the next step, which was then we needed to integrate Flutter into the native code. And for this, Google provides two options. You can either just on Android Studio on your app, create a new Flutter module and then add it onto your app and then start developing. Or else you can package your Flutter application into an AAR. And then we chose to package our Flutter application into an AAR. And this is then published to an online repo. And then this is pulled in as a dependency on the Kodeco dependencies. So this was one step completed and on to the next, which was figuring out how then do we model our data and how do we communicate the data from the native application into Flutter. So in this case, we were presented with two options. We'd either have to do our own implementation of method channels in Flutter, which is just basically a way of Flutter being able to access the native code, or else we choose to use the library that I mentioned, which is Pigeon, which basically generates that code for you that uses method channels, and then through that, you can pass your data to Flutter. And the nice good thing about it is that it is type safe. So had we gone with having to implement our own, it would have been very complex, considering that for each of the feature that we wanted to strangle into Flutter, would have to basically do the same thing. So the option of Flutter, of Pigeon, was a good option for us because then it handled the code generation and it was type safe, and it was really a no-brainer for us. So conveniently, through annotation, which you can see on the screen there at the bottom, Flutter allows you to Pigeon allows you to determine where the source of data will be. Either Flutter will request the data from native, or native will push data to Flutter, and then from there on, you choose how you want to show it. So because we're developing multiple features in Flutter, the next step was to figure out how we're going to show the specific Flutter screen as and when it's needed onto the Android application. So when we went about this, it was through entry points. So Flutter provides you a way to basically pull certain screens. So you can think of entry points as routes. So instead of basically running through the initial route, say a landing screen, you can basically define a page that you want to pull through. So since within the native application, at any point within the flow of the application, would want to pull that specific feature that we have migrated or strangled into Flutter. So entry points we found was a good way for us to achieve this. So having sorted this out, then it was time then to call our entry points into the native app and then push the data. So for a Flutter screen to show on an Android app or on a native app, then Flutter uses what we call engines. So you can think of engines as a virtual machine that basically runs, either you are running a different operating system, for those of you who have used them before, or just simply installing a virtual machine for running BlueStacks. So that's basically how Flutter engines work. So since we'll be needing like multiple Flutter screens, then that meant we're going to have multiple Flutter engines. And as you all know, virtual machines, or Flutter engines in this case, they required resources, so meaning memory. So if you had multiple Flutter engines, then it would have meant that each engine takes up its own resources. And if we spawn up multiple Flutter engines within the application, then it will lead to the application being very slow. So this is where then we discovered the Flutter group engines, which basically allows all your engines to spawn from the same place using the same resources instead of being in idle to each other. And then they can share the data with each other. So by the time we decided to go ahead with this implementation, that was already available for us. But had we decided to do it earlier, then we'd have had to find our own implementation or make our own implementation of how we're going to handle the multiple engines and their memory usage as well. So then it was on to the next step. Sorry. Yes. Pushing data to Flutter. So we had integrated Flutter. We had figured out how we're going to push data to Flutter. We had created our data model. Then it was now time to basically push the data at Flutter. So like I said, we used Pigeon, which generates a code for you. So then from this point, when using the Flutter engines, then you have to pre-warm them. Luckily for us, when registering the Flutter engines, like when you're spawning a new engine, then we preheat it as well. So if you don't do this, then what happens is then when you need to show up a Flutter screen or a Flutter feature, then you see a blank screen because then in the background, the engine is still initializing. So then we're able to get around with this, through having to preheat our engines when we're registering them and spawning them from the Flutter group. Cool. Now it was time for the Flutter final step in the Strangling. And integrating Flutter to the native app meant that the native app becomes the data source for Flutter. And the data from the native app changes, and the Flutter screen view needs to respond to those changes. So in this case, on the Flutter side, as a design pattern, we used block library, which is business logic component. And through using this library, then we're able to achieve separation of concern, and then we're able to basically respond to data changes from native. Either we are updating a single view or a full screen activity onto the Flutter side, which is then shown on the native side. So also with strangling the legacy code, one of the problems that Matt mentioned was that it is harder to maintain. So through block pattern, what we wanted to achieve is that separation of concern. So moving forward, we'll be then able to manage the code and not repeat the sins of the past. So like the saying goes, there's the light at the end of the tunnel, and now we're going to see the light after having gone through that tunnel. Right, so there's some of the features that we've successfully strangled from native into Android. So the highlighted part of the screens are the screens that are being pulled from Flutter, but as you can see, they seamlessly blends in as if it were originally there. And we've not necessarily done this for Android, but we've also done this for iOS as well. And the concept is really the same. The only difference is the syntax and also maybe the different language. But Pigeon generates that code for us as well. So we don't have to worry about platform channels and how we're going to basically handle the data going through the method channels. So with everything great comes the bloopers. So with strangling features into Flutter, some of the bloopers included not reading the documentation, as most of the developers don't. So, and we ended up with a view from Flutter that was scrolling over the toolbar on Android, and like this was simply our mistake and not basically understanding that the Flutter view comes with the Surface view, and Android already has a Surface view. So as much as it was transparent, then the Surface view was still there and making the view scroll over the toolbar. And something that's totally not our fault, Flutter 3.3 was giving errors in terms of integrating with Android. So we had to struggle with that quite a bit. But then there was a quick release of another version that we moved to, and then we were able to basically solve that issue. But also with other things that we're still going to be looking at, for example, is implementing repository pattern on the Flutter side, because currently how block works is it is using the Pigeon generated code as sort of like a service, and a block, which is more like a controller, basically accesses that directly. So we still need to add some abstraction there. But I'll let Meg tell you more about the light at the end of the tunnel. Thank you.
Cool, thank you, Mfundo. Yeah, so if everything goes according to plan, we're going to have an Android and iOS code base that's one repo altogether. This is great because it allows us to develop on one platform and deploy to two without ever having to increase our headcount. We also keep the parity, and we get to rectify the sins of our past using new design patterns and new libraries that we wouldn't have the opportunity to fix because they wouldn't normally have business value. Now there's a clear business value for us to move onto a cross-platform solution and go that way. But as always with new code comes new bugs. And as technology moves forward, even this will become outdated. But we've tried to account for that by writing all of our new Flutter features and modules. So in the case that Flutter is no longer the cross-platform tool we think we can use in 5 years, it should be pretty straightforward for us to swap it out for a new cross-platform technology without having to untangle the rest of the app like we have already. And what's next, right? So what do we still need to get right? For us, our biggest challenge at the moment is syncing. We rely on syncing quite heavily because our product needs to work offline, and it's something that we wrote custom into our app 10 years ago. For us to move that into Flutter in a strangled way, we haven't quite worked out the best way to do that yet, but we're going to try to do it endpoint by endpoint, as well as using Realm, which so far Flutter hasn't completely got Realm up and running, but it is in development. It's going to be one of the things that we do right off the bat when it's ready. But that's pretty much it. We're feeling really confident about this. You've seen the success of it for us for now, and we're really happy to be providing value to our customers as soon as possible while moving our tech stack forward. By the time we've strangled our entire app, we'll hopefully won't have strangled our teammates. That's a running joke. We'll have a modular code base entirely written in Flutter, and the original code base can be dropped and replaced by the Flutter code base. We feel like the tech is finally ready for us to be able to do that, and we're really excited. Thank you everyone for coming, and if you have any questions, feel free to ask.